Robotics, advancements in automation and human-robot interaction. Robotics have advanced significantly over the years, and human-robot interaction, HRI, is now playing an important role in delivering the best user experience, cutting down on laborious tasks, and raising public acceptance of robots. New HRI approaches are necessary to promote the evolution of robots, with a more natural and flexible interaction manner clearly the most crucial. As a newly emerging approach to HRI, multimodal HRI is a method for individuals to communicate with a robot using various modalities, including voice, image, text, eye movement, and touch, as well as biosignals like EEG and ECG. It is a broad field closely related to cognitive science, ergonomics, multimedia technology, and virtual reality, with numerous applications springing up each year. However, little research has been done to summarize the current development and future trends of HRI. To this end, this paper systematically reviews the state-of-the-art of multimodal HRI on its applications by summing up the latest research articles relevant to this field. Moreover, the research development in terms of the input signal and the output signal is also covered in this manuscript. Introduction. Recent years have witnessed a huge leap in the advancement of robotics. Yet, it is quite challenging to build a robot that can communicate with individuals naturally and synthesize understandable multimodal motions in a variety of interaction scenarios. To deliver appropriate feedback, the robot requires a high level of multimodal recognition to comprehend the person's inner moods, goals, and character. Devices for human-robot interaction, HRI, have become a common part of everyday life thanks to the growth of the Internet of Things. The input and output of a single sense modality, such as sight, touch, sound, scent, or flavor, is no longer the only option for HRI. The goal of multimodal HRI is to communicate with a robot utilizing various multimodal signals, including voice, image, text, eye movement, and touch. Multimodal HRI is a broad field that is closely associated with cognitive science, ergonomics, communication technologies, and virtual reality. It includes both multimodal input signals from humans to robots and multimodal output signals from robots to humans. As the carrier of the Internet of Things in the era of big data, multimodal HRI is closely connected to the advancement of visual effects, AI, sentimental data processing, psychological and physiological appraisal, distance education, as well as medical rehabilitative services. The earliest studies on multimodal HRI date back to the 1990s, and several publications offer an interactive approach that combines voice and gesture. Furthermore, the rise of immersive visualization opens up a new multimodal interactive interface for HRI, an immersive world that blends visual, oral, tactile, and other sense modalities. Immersive visualization, which integrates multimodal channels and multimodalities, has become an inseparable part of high-dimensional big data visualization. Great strides have been made in robotics over the past years, with human-computer interaction technology playing a critical role in improving the user experience, reducing tiresome processes, and promoting the acceptance of robots. Novel human-computer interaction strategies are necessary to further robotics progress, and a more natural and adaptable interaction style is particularly important. Fang et al. 2019. In many application areas, robots must process output signals in the same way as human beings. Visual and auditory signals are the most straightforward methods for individuals to interact with home robots. With the advancement of statistical modeling, speech recognition has been increasingly employed in robotics and smart gadgets to enable natural language-based HRI. Furthermore, significant progress in picture recognition has been made. See et al. 2020, with some robots able to comprehend instructions given to them in human language and perform necessary activities by combining visual and oral input signals. This paper systematically follows the state-of-the-art of multimodal HRI and thoroughly reviews the research progress in terms of the signal input, the signal output, and the applications of multimodal HRI. Specifically, this article elaborates on the research progress of signal input of multimodal HRI from three perspectives: gesture input and recognition, speech input and recognition, as well as emotion input and recognition. In terms of information output, gesture generation and emotional expression generation are covered. The latest applications of multimodal HRI, including assistive mobile robots, robotic exoskeletons, as well as robotic prostheses, will also be introduced. Methodology: by using preferred reporting items for systematic reviews and meta-analysis, PRISMA guidelines, a systematic review of recently published literature was conducted on recent advancements in multimodal human-robot interaction, Page et al. 2021. The inclusion criteria were I. Publications indexed in the Web of Science, Scopus, and ProQuest databases. I. Publication dates between 2008 and 2022, i.e., written in English. I. Being a review paper or an innovative empirical study. And V. Certain search terms covered. The exclusion criteria were I. Editorial materials, I. Conference proceedings, and I. Books were removed from the research. The Systematic Review Data Repository, SRDR, a software program for the collection, processing, and inspection of data for our systematic review, was employed. The quality of the specified scholarly sources was evaluated by using the mixed method appraisal tool. After extracting and analyzing publicly accessible papers as evidence, no institutional ethics approval was required before starting our research. Throughout April 2008 and October 2022, mostly in 2022, a systematic literature review of the Web of Science, ProQuest, and Scopus databases was performed, with search terms including multimodal human-robot interaction, multimodal HRI techniques, multimodalities used in HRI, speech recognition in HR, application of multimodal HRI, gesture recognition in HRI, and multimodal feedback in HRI. The search keywords were determined as the most frequently used words or phrases in the research literature. Because the examined research was published between 2008 and 2022, only 359 publications met the qualifying requirements. We chose 227 primarily empirical sources by excluding ambiguous or controversial findings, insufficient/irrelevant data, outcomes unsubstantiated by replication, excessively broad material, or having nearly identical titles. Modalities used in human-robot interaction. Several modalities are currently used in human-robot interaction, including audio, visual, haptic, kinesthetic, and proprioceptive modalities. Navarro et al., 2015. Lai and Zhang, 2017. Furlik et al., 2019. Duerlein et al., 2021. Grochel et al., 2021. These modalities can be used alone or in combination to enable different forms of human-robot interaction, such as voice commands, visual gestures, and physical touch. Additionally, some researchers work on improving the quality of interaction and the perceived intelligence of the robot by incorporating tools like natural language processing, cognitive architectures, and social signal processing. Audio modality. The audio modality is an important aspect of human-robot interaction as it allows for verbal communication between humans and robots. For robots to effectively understand and respond to human speech, they must be equipped with speech recognition and natural language processing, NLP, capabilities. What do you think of our video? Let me know in the comment section below. Before you go, please hit the like button and subscribe to my channel. Thanks for watching.